To part 3 of my notes on volume of a rectangular prism. So today's part 3 of our notes, I'm actually on page 4 of the packet, so 6-4, is going to look at word problems. And here is the first one called example 4. So we have a part A and a part B. It says, what effect does tripling the width, length, or height of a prism have on its volume? So if you remember from the previous 2 days, we learned that if you change one attribute, it will have the same effect on the volume. For example, if you double just the length, then it will double the volume. Or if you want to take half of the length, then it will cut the volume in half. So to answer this question, it says, what effect is tripling the width, length, or height, which means we're only doing one at a time. That's what, by saying the word or, we're only doing one at a time. So if we triple just the width, just the length, or just the height, that means that the volume will also triple. So we can say the volume will triple. Okay, part B says a rectangular prism has a volume of 12 centimeters cubed. If the height of the prism is tripled and the other dimensions stay the same, what is the volume of the new prism? Okay, I'm going to show you two ways to do this. Okay, the first way is if we know the rectangular prism has a volume of 12, we can make up our own measurements. Okay, so the formula is length times width times height. And I know that I have to think of three numbers that multiply to give me 12. Okay, so I can use any three numbers that multiply together to give me 12. Well, I know 4 times 3 is 12, and I know 4 breaks down into 2 times 2, so I can do 2 times 2 times 3. So I know that those three numbers give me 12. Now, if the height is tripled, so we know that the numbers I just made up, the height is 3, so if we triple the height, we multiply it by 3, and 3 times 3 is 9. So I can say, okay, this is 12. So if I change 2 times 2, I'm going to keep those two the same, and I'm going to change the height to 9, because we're tripling it. And 2 times 9, of course, is 36. So we know that the volume of the new prism is going to be 36 centimeters cubed. Now, let me show you a much easier way, and I don't like the way I set this up. So let's go back to that and just write it like this. Okay, and that's 12 centimeters cubed. Now I'm going to show you an easier way, which is probably the way that you'll want to use, but I wanted to see where it came from. So watch. If the original is 12, and I know if I triple the height, it triples the volume, then all I need to do is take 12 centimeters cubed times 3, because if I triple the height, it triples the volume. So 12 times 3 is 36 centimeters cubed. Now you might say, why did I do this when this way is so much easier? I wanted to show you this way so that you could see where it came from. And this is actually the proof behind this answer. Okay, so let's look at example number 5. It says a rectangular prism has a length of 12, a width of 15, and a height of 9. What is the volume of the prism if the width is decreased by a scale factor of 1/3? Well, we learned previously in this unit that scale factor is the number we're multiplying by. Okay, So let's underline keywords before we get into that. So the length of 12 centimeters, a width of 15, and a height of 9 centimeters. So I want to find out what the volume is if the width is decreased. Underline width, decreased by a scale factor of 1/3. So before I can do length times width times height, I've got to change the width by a scale factor of 1/3. And we know scale factor means the number you're multiplying by. So I'm going to multiply the width by 1/3. So let's write W equals 15 times 1/3. Now remember, when you multiply fractions, if you have a whole number, you turn it to a fraction by putting a 1 underneath it. And we can actually cross cancel here because I know a number that goes into 15 and 3, and that number is 3, so 15 divided by 3 is 5, and 3 divided by 3 is 1, and 5 times 1 is 5, 1 times 1 is 1, and 5 divided by 1 is 5. So the new width is 5. Now I can calculate the new volume. So I can come up here and just cross this out lightly and put a 5 there. So now I write the formula length times width times height. We know that the length is 12. We know that the width is 5 because I just calculated it. And the height is 9. So 12 times 5 is 60. And 60 times 9 is 540. So my new volume is 540 centimeters cubed. Okay, now some of you might have been looking at this and going, is there an easier way to do that? Yes, in our last unit we learned that multiplying by 1/3 is the same as dividing by 3. So if you know that, you could have just did 15 divided by 3 is 5. Okay, so for future reference, but if you know that scale factor means multiplying, you know how to multiply fractions, this really isn't a bad method here. Okay, so let's look at example number 6. And after we do number 6, that concludes our notes. So, a rectangular prism has a height of 4 inches and a volume of 40 inches cubed. The height of the prism is changed to 8, and the other dimensions stay the same. What is the volume of the prism with this change? Okay, so once again, I'm going to show you both ways so you have something to go by. Okay, so rectangular prism has a height of 4 inches and a volume of 40 inches cubed. The height of the prism is changed to 8, and the other dimensions stay the same. What is the volume of the prism? So we know that the height is changed to 8. Other dimensions stay the same. What is the volume with this change? Okay, so one thing we can do is we know what the volume is and we know what the height is, so we can calculate the length and the width of the original figure, okay? And then we can use that to calculate the new volume. So we know that we have the formula is length times width times height. And right now we know that the height is 4, and we know that the final answer is 40. So we have to think of numbers that multiply together. Sorry about that. We have to think of 3 numbers that multiply together to give us 40, and we know that one of the numbers is 4. So we know that 4 times 10 is 40, but if we break down 10 into 5 times 2, then we can have our 3 numbers. So let's say that the length is 5 and that the width is 2, and 5 times 2 times 4, of course, is 40 inches cubed. Okay? So that is the original volume. And now we have pretend measurements, okay? And we can use those pretend measurements to calculate the new one if the height was changed to 8. So if the height was changed to 8, that means we're going to leave the length and the width the same. So let's write the formula again. We're going to leave the length at 5, the width at 2, and we're changing from 4 to 8. And 5 times 2 is 10, and 10 times 8 is 80 inches cubed. Now, this is the proof behind it, because, look at what I did to the height. All I did to the height is change it from 4 to 8. So what did I really do? I doubled it. So all you really had to do is do this. You could find what the scale factor of the two heights are. And remember, we learned a ratio called new over old. So what's the new height? It's 8. What's the old height? It's 4. And 8 divided by 4 is 2. So that means the scale factor is 2. So let me write down, go back and write scale factor equals new over old, and 8 divided by 4 is 2. So we know the scale factor is 2. So if the height doubled, that means the volume is going to double. So we can take 40 inches cubed and multiply it by 2, and 40 times 2 is 80 inches cubed. Okay, now circle this, and you may want to box this in because this, oops, that's not really a box, but we'll go with it. This is probably the easier way, but some people like to figure out the measurements and go with this way. So I wanted to give you both options so that you could decide for yourself which way you like better. Okay, that concludes part 3 of our notes. I hope you have a great day.